Hello everyone, I am Romel Carlo Valdivieso and I will discuss to you about differentiation and integration of power series. Theorem 9.21 Properties of functions defined by power series. If the function f of x is equal to the limit of n is equal to 0 raised to infinity, so a sub n times x minus c raised to n is equal to a sub 0 plus a sub 1 times x minus c plus a sub 2 times x minus c squared plus a sub 3 x minus c cube plus and so on has the radius of convergence of r greater than 0, then on the interval c minus r and c plus r, f is differentiable and therefore continuous. Moreover, the derivative and the antiderivative of f are as follows. The antiderivative of n is equal to 1 raised to infinity na sub n times x minus c raised to n minus 1. So the answer is a sub 1 plus 2a sub 2 times x minus c plus 3a sub 3 times x minus c squared and so on. The integral of f of x dx is equal to c plus n is equal to 0 raised to infinity a sub n times x minus c raised to n plus 1 over n plus 1. So the answer is c plus a sub 0 times x minus c plus a sub 1 x minus c squared over 2 plus a sub 2 times x minus c cube over 3 and so on. The radius of convergence of the series obtained by differentiating or integrating a power series is the same as that of the original power series. The interval of the convergence, however, may differ as a result of the behavior at the endpoints. Example: interval of convergence for f of x and the antiderivative of x and the integral of f of x dx. Consider the function given by. Find the interval of convergence for each of the following. So the solution by the theorem 9.21, you have the given. So it equals to 1 plus x squared plus x cubed and so on. And the integral of f of x dx plus is equal to c plus n is equal to 1 raised to infinity. X raised to n plus 1 over n times n plus 1 is equal to c plus x cubed. X is equal to c plus x squared over 1 times 2 plus x cubed over 2 times 3 plus x raised to 4th over 3 times 4 plus and so on. By the ratio test, you can show that each series has a radius of convergence of r is equal to 1. Consider the interval -1 and 1. You have the following. The solution n a for integrate f of x dx, the series. Interval of convergence -1 and 1 converges for x is equal to positive, negative, and its interval of convergence is -1 and 1. See figure 9.21. So we get the interval -1 and 1 and radius is equal to 1. Solution in B. Converges for x is equal to negative 1 and diverges for x is equal to 1. So its interval convergence is negative 1 and 1. See the figure 9.21. B. Diverges for x. X is equal to positive negative 1 and its interval of convergence is negative 1 and 1. See figure 9.21c. And that's it. Hope you learned something new today. Thank you. And see you in my next video. Bye.